This is a timer light. It will come on for a short period of time and then go out. I'm going to turn on the slide switch and the color LED turns on. Pushing the press switch will make it reach full brightness, and then from there it's going to gradually go out. The RV3 resistor is used to control how long it stays on. The RV resistor is only used as a fixed resistor in the circuit, so its lever will have no effect. The primary part of this circuit is the C5 capacitor, which, like other components of its kind, stores electricity. But this circuit works in the reverse principle of other similar projects that I have demonstrated in other sets. Instead of the capacitor slowly discharging while the color LED is on, it is slowly charging. And then once the capacitor is full, the LED will go out. And this is a lamp similar to that that might be on your built into your watch or the backlight of your phone, which will go out after a short period of time to avoid draining the battery. I replaced the adjustable resistor with the R3 resistor, so depending on the setting of the RV3 resistor, the color LED will go out more quickly. And I'm not going to record it actually going out because it will still take too long, but I'm sure you understand the principle of circuits like these. Here's a timer light that is easier to adjust. When you push the press switch, the color LED will come on, and the brighter it is when on, the faster it will get dim. This is actually the longest setting because it is dim when it comes on, but then it will use less electricity from the C5 capacitor. And then the adjustable resistor, once again, is a fixed resistor. Here I replace the adjustable resistor with the R3 one, and now the color LED will only come on over a small range of the RV3 resistor, and it will also go out faster, as you can probably already tell. And that's that with the timer lights right now. Here is a light that only comes on when there is light around it. When I cover the photoresistor, the color LED goes out. When I remove my hand, the LED comes back on again. In this particular circuit, electrical resistance increases when the photoresistor is covered, keeping the color LED off. It decreases when I remove my hand. The adjustable resistor controls the sensitivity of the photoresistor. Now this is a daylight that can work in darker rooms because here the photoresistor is more sensitive. As you can see, even though my hand is hovering completely over the photoresistor, the LED, although a little dim, is still on nonetheless. Only when I completely put my hand over the sensor will the color LED turn completely off. And the adjustable resistor is used to control the sensitivity of the photoresistor. This light works on the opposite principle of the daylight from Project 74. Instead of coming on when there is light on the photoresistor, it comes on when there is little to no light. I'm going to turn on the slide switch, and there is insufficient light on the photoresistor, so electrical resistance is low and the LED is on. You can use the RV3 knob to adjust the sensitivity of the sensor, and then when you shine a light on the photoresistor, hang on, the LED turns off as electrical resistance increases. This is the exact same principle of a street light or other type of outdoor light that comes on only when it gets dark out. These lights come on at night, and they may also come on during unsafe conditions like thunderstorms. With this circuit, you can blow into the microphone and hear it on the speaker. I am going to do just that. And you can hear the electrical noise on the speaker. And like I explained earlier, the electrical resistance in the microphone changes when you blow or talk into it, or you make loud noise by it. Now, this project is very interesting in that you can actually listen to the light change. How do you do that? Well, when you turn on the slide switch, listen to the noise. Now, the color LED, how this works is that the color LED actually has 3 separate lights, as I have explained before. They are red, green, and blue. And then a microcircuit controls them. And when the LED changes colors, the voltage changes. And whenever you hear the voltage change, you hear a click from the speaker. Here you can adjust the volume of the sound produced by the voltage change with the color LED. You can make it quiet or loud. But other than that, the principle of this project is essentially the same as the previous one. The transistor is used to amplify the current flowing through the LED, and therefore to make the speaker sound louder.